this video, we will deal with our first class in Java, the string class. We will learn how it works and how to use it. A string is a sequence of characters that are combined to represent a text. This text could represent anything, a name, an address, or even a paragraph. We are familiar with strings because we have seen them as literals in our print and print line statements. Now, what if we want to use a string without being a literal? We want to give it a name, like say, for example, first name refers to John. The problem is that none of the 8 primitive data types in Java represents a string. That's why we need to use the string class that comes with Java. Since the string is a class, this means that the strings in Java are objects. To understand the string class, it's essential to know how the computer deals with objects in the memory. Remember our stack memory, which was the stack of memory bytes? When you initialize a primitive data type, Java reserves the number of bytes appropriate for the data type, then it stores the data inside the variable. From now on, in our illustrations, we will use a simplified view of the stack memory, assuming blocks of memory. So for primitive data type, the data are actually stored in the variable in the memory. Now, what happens in the memory when you create an object? Remember, an object is a complex identity that consists of fields and methods. For simplicity, we will from now on represent an object as a box. Each one of the fields could be a primitive data type. The methods are blocks of code. So an object is a very complex entity and clearly cannot fit in the stack memory. And that's why an object lives in a different portion of the memory called the heap memory. It allows for more flexible storage. To declare a string object in Java, you type the keyword string, which is the name of the class, followed by the variable name that you want to use. For example, in our case here, string name. What this declaration statement does is to create a variable in the stack memory called name. Then you assign a string to this variable, which will create the complex string object in the heap memory and populate it with the string Joe Mahoney in our example. So clearly, the object that we just created has 2 parts. One of them is the reference in the stack memory, and the other is the actual object in the heap memory. So how do we connect them? What will happen is that the name object in the stack memory will hold the memory location of the complex string object in the heap memory. This way we use the flexibility of the heap memory to store the complex objects and also keep things simple in the stack memory. That's why the name in this example is referred to as a reference variable instead of just a variable, because it actually references the complex object in the heap memory instead of storing it like in the primitive data types. So once again, objects are not stored in the variables. Instead, they are referenced or pointed at by the reference variables in the stack memory. There are 2 ways to create strings in Java. The one way that we have just seen, which is a string reference variable equal to a string literal. The other approach is to use the keyword new, a keyword that tells Java to create a new object in the memory. Both ways are valid and can be used. Then why do we have 2 approaches to create strings in memory? You will notice that the first approach looks very similar to declaring a primitive data type in Java. Since the strings are very common, Java made an exception for the string objects and allowed them to be created using the initialization statement like this. Every other object in Java can be created by only using the keyword new. Also notice that the S in the string must be uppercase since this is the name of the string class. This matches what we learned so far, which is that identifiers for classes are always capitalized. The last thing we will cover about string class is that since the string is an object, it must have methods. So the string class comes with a large number of useful methods. One of the methods is called length, that can be used to get the length of a string. The way you use it is to use the strings identifier followed by a dot and then the length method with empty parentheses. You will probably want to listen the following statement multiple times because it summarizes all we know about Java so far. What this line, which reads int string length equal name.length parentheses semicolon does, is that it calls the method length for the string object referenced by the reference variable name, gets the integer length, and assign it to an int variable string length. Please make sure not to leave this video before you fully comprehend this sentence. Strings are immutable, meaning that if you create a string object, you can't go and change its contents anymore. Other methods that we will learn and use are the char at method, 2 lowercase and 2 uppercase. The char at method is a string method that takes an integer index and returns you the character in the string that corresponds to this index. So what it takes as an input between the two parentheses is an int index, and what it returns to you is a char. It's important to remember that indexing in a string starts from 0, not 1. So this means a string that represents the name John has 4 characters, starting from 0 and stopping at 3. The length method takes no inputs, which is why we have empty parentheses in this case. For the 2 lowercase, it takes no inputs as well, but returns a new string that is an all lowercase version of the original string. Notice that it doesn't change the casing of the original string. Instead, it returns a brand new string object with a string similar to the original string, except that it's all lowercase. 2 uppercase does the same thing, except that it returns a string that is all uppercase. These string manipulating methods are useful. For example, assume that you have a database of emails that has all data stored in the all lowercase strings. Different users can enter different strings with different cases. So if you want to match the input to your database, make sure it matches the casing by converting all of it to all lowercase first, and then search your database. This is a demo for strings using the string class provided by Java, and also how to use the methods or a few of the methods that the first thing I'm doing here, and please be very careful with the wording and the terminologies I'm using. So for example, here I'm defining a string object, which is referenced by a reference variable called message. So here what I'm saying is that I'm using the keyword string for the name of the class, right? Which works as if it's a data type in this. The reference variable is called message. This is not where the actual string is stored. It stores in an address that points to the string in the heap memory. That string object that is stored in the heap memory, it contains that string literal, which is called Java is great fun. Alright, so be very careful. This is very, very important concept that message is not the actual container of the Java is great fun. Message is just a container of an address that is going to point to Java is great fun object in the heap. So if I try to print something like this, I'm going to compile. We get Java is great. Message before we used to put that literal here, but now we have that flexibility, right? Now before we move forward, I'm going to tell you here that I could actually define it using the new keyword. So I could say string, all right, message is equal to a new object from string that has the literal Java. If I compile, that will run also. I get the same output. So these are 2 possible ways to declare a string object in Java. All right. Now notice here that the string class or a string object is the only object in Java that can be declared by these 2 approaches. All right. This is something handy. This is something very nice that you can actually create a string that easy if you are declaring and assigning a regular primitive data type, even though it's not. But that flexibility is just exclusive to strings, no other object. All other objects should be created using the new keyword. All right, so now that we have message which contains that or points to the string object in the memory, all right, so it doesn't contain it. So since we have that reference variable now I can operate on it. I can actually go, for example, here and say I'm going to create another string called upper, which is going to point to whatever string that this method is going to return. And this is a very important concept you need to understand. Message dot to uppercase, what it does is that it returns a string that is all uppercase version of message. So it doesn't go and change message. Message is the same. Message will always remain as Java is great fun as you see it here. What it does is that it takes this, all right, create another object in the memory, the heap memory, another string object, and then takes Java is great fun and makes another copy that is all uppercase and store it in that new object. So what this is going to return is a completely new string object in the memory. So what you want to do is to point to that new string object by creating and declaring another reference variable for a string. All right, and that's why we say string upper is pointing to or equal to message.uppercase. All right. Now, one thing you could do actually, if you don't want to create a new reference variable, is to just print that. So you could say system.out.print line, right? And just take that part here and put it as the argument for the print statement. In this case, it's going to print Java is great fun as all uppercase. All right. So this is exactly the same. If you do it this way, this is going to give you the same output. Java is great fun. All right, so using the same approach here, I could do the same thing with lowercase. To lowercase method, which takes no input. And notice here that it takes no input because it knows what string it's operating on. You don't need to tell it take to uppercase of that string. Instead, you're saying from message, which is that string object, I would like to convert it to or to create a to uppercase version of it, right? So to uppercase knows very well which string it's going to try to make to uppercase, which is the string pointed to or pointed at using message. So the same goes with to lowercase. If I compile and run, it's going to create an all lowercase version of this string. All right, the next one is char at, and char at, as we said, this is one method that needs to take an input, because I know you want a char at, which is a character at certain position of the message, but you need to tell me where is this located, right? So that's why I need an index, an integer index that is within the bounds of the actual string, so I can go and extract that character for you. All right, now notice here that since it's char at extracting a character, this means it's returning a char data type. So that's why you need, if you want to store it somewhere, you need to store it in a char data type variable. All right, and that's why we create char letter, store the character that will be returned from the char at method of the message string. Does that make sense? So that's what is really happening here. Now, which character should be returned from the keyword from the string Java is great fun? So if I tell you from that message, I would like to extract the character at 2. So which one will it return? So here I can expect two answers, either A, because that's the second place, or V, and the correct answer is V. Why? Because V is located at the second location, the second index, which counts from 0 for the J, 1 for the A, and then 2 for the V. So notice here that the indexing of a string starts from 0. You need to be very careful. Everything we are doing here, even our lab, starts from 0. First lab you completed was lab 0, right? So in computer science, everything starts from 0. Indexing starts from 0, and that's why 2 here doesn't really mean the second place. It means the index 2, which is the third place. The last method that we can think about is, or we learned, is the length method. And the length method, what it does is that for the message or the string object pointed at using the message reference variable, it's going to go and apply the length method. Again, I don't need to give it any information between the parentheses so it can work, unlike char at. So here what I'm actually doing is that I'm telling it, get the length of the message, which message is pointing at this string. All right, so what it does is that here 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 13, 14, and then 15, 16, 17. So a total of 18 characters in that string. All right, so if I store that, that's going to be an integer. 18 is an integer, right? The length must be an integer. So in that case, I store it in an int data type. So int string length is equal to message.length. So compile, run, and I try to print it here. It's going to print 18. The last thing I would like to point out is that if you try to access a string, a character using char at that doesn't exist, it's going to give you an error. Right? So I know that I have a total of 18 characters, but I have to be very careful and remember that it starts counting from 0. So this means I actually have indexing from 0 to 17. Right? 0 to 17 gives you a total of 18. So in this case here, what happens if I try to access, for example, the 17th character? So that should work because I have 18 characters. It goes from 0 to 17. So 17 means the last one, which is going to be the exclamation or exclamation. So in this case here, if I run this void, so that's exactly what we got. All right. Now, what if you forget? What if you forget and say, okay, I have 18 characters, then the last character must be at the location 18. So if you try to do this, Java's not going to complain about it when you compile. So it's not a compile time error to try to access a character that doesn't exist. Instead, it's a runtime error. So see here, string index out of bounds exception. So that's an exception. Exception is something similar to an error. We will talk about this later on. And what it's called is that it's string index out of bounds. So that's very descriptive error or exception. It says that you have a string that you try to access an index that is out of its bounds. It's very, very straightforward and simple. And it tells you where. It tells you in line 18, which if you click here, it tells you that this is in the line 37, which if you click here, it's going to highlight that line for you. It tells you are trying to access something which this index is 18. You're trying to access the 18th element or character in that string, which doesn't exist. All right, so that's an error that you could and many programmers really do this mistake. It's very possible. But the nice thing is that when you read an error like this, you should be able to locate the error and understand, oh, I tried to access and I didn't take care of that, the bounds. So in that case, you go and revise the indexing and start counting from 0 again and so on. So that's it for the string and how to use its methods.